Hey, fellow mathers, we are in the midst of the free Math is Figureoutable challenge and would love to have you join us.
Register at mathisfigureoutable.com/challenge and we'll make sure you get all the details you need.
You can expect high energy, engaging sessions along with new free downloads, special guest appearance, and tons of prizes.
It's happening this week, January 21st through 23rd at 7 p.m. Central Time. There's still time to join us. Register at mathisfigureoutable.com/challenge. We'll see you there.
On to the episode. Hey, fellow mathers. Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
And we're glad you're with us on that mission because we know that algorithms are amazing achievements. But they are not good teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems could be developing.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
Thanks for joining us to make math more figure-outable.
Hey there.
Hi. How's it going?
It's good.
Is it cold where you are?
I mean, I'm like 20
15
minutes
miles
away
down
from
the road for me. I haven't been outside. I think it's cold.
That's hilarious.
Well, cool,
You
maybe.
know, I do have teenage boys, and so it's January, and mine rolled out of the house with shorts and a t-shirt on. And I said, hey, just so you know, it's probably a little cold outside, but you do you, buddy.
I mean, here in Texas, you never know, right? Like it could be.
I mean,
up and down.
On, put a jacket on. I used to, when I taught elementary school, I would see these kids and I'm like, come on, parents, like put your kid in a jacket, Oh man, I'm like eating my words.
Did you have to eat some words? Yeah.
Oh, 100%. Like whatever.
One of the first things
one of
the first things I ever tell new parents is like, never in your life ever say the words, my kids will never. Like just strike that from your vocabulary because as soon as you say the words out loud, karma will strike.
Yeah.
And that'll be the exact thing that your kids will, Right.
Well,
right?
and they need experience to learn, right? I could shove a jacket on them, and that might be a fun fight. But learning is through.
Learning's a good thing. Yeah, yeah. Young parents,
anyway, so
don't ever say the words. My kids will never. Just don't do it.
All right.
What
we're gonna talk math today.
What are we doing in this podcast episode? We can do math. I like math.
Yeah.
Math is good. Okay, math. Yeah.
Okay.
Yeah.
So, we are big fans of problem strings as a routine.
Big fans.
And we do problem strings quite a bit, but not too terribly long ago. Somebody asked if we had a video of a good number talk, which we call problem talks because they're about problems. And we thought that we would today describe the way that we think a good problem talk could go in a classroom.
Yeah, nice. Number talks can be good, right? They can be good. We just think that if you're going to do them, you're going to do problem strings a whole lot more than you will a number talk or what we call a problem talk.
Say why.
Problem strings give kids a higher dose of the underlying relationships and the strategies, a high enough dose that kids actually can build them. Number talks, we most of us, when we first saw a number talk, we were like, oh, this is amazing. There's more than one way to solve a problem. And look at all the ways people are thinking, and I can learn from that, and didn't get a high enough dose. And it felt like in that, so see if everybody agrees with me, but it could have felt like in that moment that there's this vast, unknowable, unnumerable, undescribable set of strategies that's like whatever anybody does is cool. And I didn't even follow that one. Do I have to learn that? Do I have to teach my kids that? Instead, we're suggesting there's just a small set of major relationships that lead to a small set of major strategies. We need to know those as teachers so that we can high dose kids with those relationships to lead to those strategies so that then everybody is mathing the way mathy people math. Number talks don't do that well, but problem talks, what do they do well? Well, they compare strategies well. So if we do a good number talk, problem talk, once we've planted the seeds of these important relationships and kids have developed a few of the strategies, that's a great time to do a number talk or what we call a problem talk. because now we can compare strategies for efficiency, and we
Mm-hmm.
can get kids better at the strategies in that comparison.
Mm-hmm.
We can help kids develop intuition about when to use which strategy. Did I leave anything out?
Yeah, I'll add on that there are some nice times to do a problem talk, although I agree with you that a problem string would be happening much more often in my classroom. A problem talk is a nice chance to put up a problem every once in a while to see what strategies are being used by students. The
Yeah.
beginning of the year might be a good time to put up a problem and say, like, what do my kids think about? What are they owning before I start the work that I'm doing with them? So there are a couple of nice opportunities to use problem talks. And today we're going to chat about what we think they could look like.
I have a question for you.
Yeah.
When you say that it would be a good could be a good opportunity, say like at the beginning, to sort of see what your kids are doing. How much time would you spend in the discussion of that number talk or problem talk, comparing those ways that kids were?
Are we talking like beginning of the year?
Yeah, like you
that's what I
don't
was
know the
thinking.
kids yet.
Yeah, I don't know that I'm going to spend too much time. That's more formative for me. That's like, hey, what? First of
You're
all,
almost kind of gathering that, like picking it up.
Yeah, like
you're
do
not spending. Yeah,
my kids talk about their thinking, or is it pretty quiet? Do they break apart numbers? Do they, like, what kinds of things are they saying? And then I kind of gives me some information about where to start. Like if they have fantastic strategies and like tons of kids are nodding and they're into it and they're chiming in and adding on, then it's just one way to assess what they come into the grade level with.
Nice. What I'm not hearing you say is that this is like a teaching time.
No, no, not
like where you're really like, okay, everybody,
no.
you got this one, like really good, really down. Like
that's not how I use problem talks.
It's more formative.
Yeah.
Okay,
Yeah.
cool. So let's say that we are in a place where we think a number talk is a good one to do. So Kim, let's do a number talk today. I feel like you were going to say something else to set the stage. No, we're good. Okay, so I'm going to give a problem, and listeners, we would invite you to solve that problem. Try to use relationships. If you are someone who's built a few strategies, maybe think how many strategies can you come up with, or how many of them are major? Which ones would you be thinking about pulling out of your students? Blah blah blah. Okay, so here is a number talk, what we call a problem talk, that we're going to do today. And Kim, that is 15 times 36. So class, 15 times 36, solve it any way you want. Try to be clever. Try to be like efficient and clever, slick. Try to like find a slick strategy. Go. I'm going to give that to students. Then I'm going to circulate and see this. I would suggest that this would not be one of those where there's no paper and pencil. So kids might have whiteboards. I don't know, whatever I don't care how they're writing. It doesn't need to be formal in a notebook or something. This is kind of scrap paper time. Could be could be drawn on their desks with whiteboard markers, whatever. I'm going to circulate, kind of see what's happening. Once enough kids have chewed on that problem well enough, might have asked a couple kids what they're thinking. If I can't kind of tell they're not representing their thinking very well, I'll come back to the board and I'll say, all right, fantastic, Kim.
Yep.
Tell us how you were solving 15 times 36.
Well, I'm really glad that you talked for a minute, because I was like racking my brain of all the different ways that I know you're going to ask me for more than one. Yeah, I'm good. Okay, so my first inclination was to think about 15 times 36 as an over strategy. So I actually thought about that like 40 times 15.
Okay.
Which is 600. And then I didn't need 40 15s. I only needed 36 15s. So then I subtracted 4 15s. So then I wrote 40 times 15 minus 4 times 15 is 36 times 15. And I wrote 600 minus 90 is 540.
Minus 90
is 540.
Is 4 times 15 90?
Did I say 90? No,
yeah.
600 or 60. Sorry. I literally wrote 90 on my paper. And then, funny enough, I wrote 540.
Wow. There you go. Wow. So I think you were thinking 60. For whatever reason, you wrote 90. Yeah. I think you were thinking 60. Yeah, cool.
That's hilarious. Okay.
So if a kid were to, first of all, they might not be as clear as you were. If a kid were to say exactly what you just said, I might write on the board 40 times 15 equals 600. 4 times 15 equals 60. And then draw a line. And then write 36 times 15 equals 540.
Okay.
But I'm thinking about what I don't want to do too much teacher talk right now. I think I might also say that that it feels like Kim was thinking about 15s. So I asked the question 15 times 36, but I don't think that you were thinking about 36s. I don't think you found 15 of them. So if you're thinking about 15s, I could also represent your strategy on a ratio table. And I've just drawn a vertical ratio table where I've got 1 to 115, so 1 to 15, and you found 40 of them was 600. So now I've got a ratio table that it's vertical. It's got 1 to 15 and 40 to 600, and then 4 to 60, and then 36 to 540. So it actually looks kind of similar to what I have in the equations as far as the numbers go, but it's sort of in that table next door. Cool. Yeah, it's just got me thinking. I think because of where I think I'm going with this, no, I'm just going to say it, what I would say to kids. I'm also going to represent that as a 15 by 36. So everybody help me draw that rectangle. If this was 15, the 36 should be, and I'm looking for somebody to say, well, sorry, Kim, if I've drawn 15 down, what would the 36 across look like?
It's going to be more than twice as long.
More than twice as long. So I'll kind of there and then that. So I've got a rectangle that's 15 down and more than twice across. But you didn't really find the area of a 15 by 36, not off the top. You found an area of 15 by 40. So I'm going to draw a little bit, like tack on a little bit. I've now stuck the 36 inside the rectangle. So 15 by 36. There's that little 4 hanging over on the side. You said that, so now I have a 15 by 40. So I've written 40 across the top of the long rectangle because I stuck that extra little bit on the side. And you said that 15 times 40 was 600. So now I have a caret below the chunk that was the 15 by 36, connecting it to the 15 by 4. You said that total area was 600. The 15 by 4 area was 60. So the leftover area is 540. So I have 3 models on the board for this one strategy. And I'm sort of curious. I might have students like say to themselves, which of those models speaks to your heart and your soul? Which of those helps you kind of understand Kim's strategy better? Cool. All right.
Okay.
Now I might say, great. Now I want to, I'm going to call on another kid. How did you solve this problem? Is that Kim 2? Do we give him a new name? Is that?
Everybody needs more Kims. Yeah. So a second student.
New kid. Yep. Okay.
A new kid might say, I broke up the 15 and the 36 into place value parts. And so then I did 10 times 30 and 5 times 30 and 10 times 6 and 5 times 6.
Cool. So I'm going to redraw that 15 by 36 right underneath the area model, the rectangle that I had above. And so now I have 2 15 by 36s, but I don't have that extra tacked on the end. I just have the 15 by 36. And Kim, you said that you broke up the 15 into 10 and 5. So about 2/3 of the way down, I've now drawn a horizontal line. And in the inside of the rectangle, I've drawn a 10 and a 5. And then you broke the 36 up into 30 and 6. So way over to the right, a little bit bigger than the 5 across the bottom is a 6. It looks kind of the same because 5 and 6 really when you're dealing with. But I'll probably say out loud a little bit bigger over here because this is 6. So now in the inside, I have 30 in that inside rectangle, and then I have 6 over on the edge, that sort of strip that's going down below. So the 2 rectangles are right above each other, that one for the 15 by 40 strategy, and right underneath it, I have copied that 15 by 36, but now I've cut it into 4 chunks. And then Kim, I'll let you keep going. What is 10 times 30?
300.
So that's that one of those inner rectangles area, and then 5 by 30.
150.
And then 10 by 6.
60.
And then that last little tiny one down there, 5 by 6.
30. And
then if we add all those up together, did you also get 540?
I did.
All right, so if we add all that together, 540. All right, so Kim number 2, nice strategy. I might step back and say, between these 2 strategies, does either one of them feel more efficient? let everybody think. I might even invite kids to partner talk at this point. Which of those two strategies feels more efficient? Cool. Kid number 3, what are you thinking about?
I just broke up the 15. So I did 10 times 36 is 360, and 5 times 36 I knew was half as much as the 10 times 36. So that was 180.
Cool. So I've redrawn the 15 by 36 again, right below. So now I have 3 15 by 36s, bam, 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 right on top of each other. One of them has that little extra 4 on the end. One of them's cut into 4 chunks. And this one, can I just redraw? This one looks terrible. Hang on. Oh, wow, I can't draw straight today. Okay, so this one, you broke the 15 into 10 and 5. So that's going to look very similar to how I cut the rectangle right above it into 10 and 5. But then I'm not cutting it vertically. I'm just leaving the 36 alone.
Okay.
And then what did you do after that?
I did 10 times 36 is 360.
Okay, so that's the area of that big top chunk.
And then I knew that the 5 times 36 was going to be half as much as the 10 times 36. So that's just 180.
Nice. Cool. And then when you added those together, did you also get 540?
Yep.
Cool.
Yep.
Now, I might invite a conversation with the whole class. What do you think about these 3 strategies? Then I could point to them because I have 3 rectangles on the board. What do you think about these 3 strategies? And I want to have a conversation. What do you think about that? Do they make sense to you? Might they occur to you? Which one do you want to occur to you next time? Which one feels kind of clever and efficient? You're hoping that occurs to you next time. Kim, can you envision a kid saying something in that class discussion?
Yeah, I could see one of the kids saying that's something they hadn't thought of before might be nice to think about. Like if a kid had never thought of over, they might say that. If a kid broke up both factors, they might like to break up just one.
Cool. I could also envision a kid saying something like, well, the middle strategy had 4 chunks and the other 2 just had 2 chunks. So that might speak towards efficiency. You could also envision a kid saying, yeah, and that one subtraction, I don't really like subtraction. I'd rather add. But then a kid might say, yeah, but you had to divide the 360 in half. And I'd rather like just use the sort of place value things that were happening with the 600 and the 60. So the subtraction wasn't very bad. So I could see that this could be a nice conversation, where they're like, no, I hate subtraction. Really? But 600 minus 60? No, but it's just easier to add. Yeah, but really you have to divide, and so, yeah, so I could imagine that conversation. Cool. All right. Kid number, let's say, I think 4, right? We're at kid number 4.
Yep.
Kid number 4. How did you solve it?
I could see that a kid would see that it's a multiplication problem and want to add a bunch of 15s together because then they can add all the 10s together and add all the 5s together. 10s and 5s are pretty simple to chunk.
If you're going to add a bunch of stuff together, you might great. So if a kid says, yeah, I started adding a bunch of 15s and I was bringing these together, I might say, that's interesting. Are we looking for 36 15s? Sure enough. Next kid. So I'm going to choose in this moment to say, are we doing that? Everybody nods. I'm like, yep. And then not represent that repeated addition on the board. So I'm going to acknowledge it positively. Yep, we could do that. Nice. Kid number 5. What do you got?
Kid number 5 could say, I know that 36 is close to 40. So I thought about that like 15 times 40 minus 15 times 4.
And in that moment, I might say, kind of like, and then I would point to the first rectangle that I drew. And I would say, so you were thinking about 15 times 40. And I would point to that 15 by 40 that we already have drawn on the board. And what did you do?
I subtracted 4.
Hey, and 50. There's right here it is. There's the 4 15s. Sorry, I'm interrupting.
No, but
here's the 4 15s. So does this represent what you were thinking? In that moment, depending on how the kid answers, I'm hoping the kid goes, yeah, that represents what I was thinking. And I might go, okay, yeah, that is a nice strategy, just like Kim number 1 did. Nice. So I'm not going to redraw or re-represent the same strategy, even though the kids said it differently.
Mm-hmm.
If it's using the same relationships. Okay. Kid number, I don't know what number we're on. Are we on 6? Kid number 6.
I could see another student say, I'm going to break up the 15 and call that 3 times 5, and break up this 36 and call that 6 times 6.
So I've got written on the board right now 3 times 5 in parentheses times 6 times 6 in parentheses.
Mm-hmm.
And I should say I rewrote 15 times 36, and I rewrote 15 times 36, and underneath it I wrote the quantity 3 times 5 times the quantity 6 times 6.
Mm-hmm.
Okay, random. What? No, I wouldn't say that to a kid. I might go, that seems really weird.
Yeah, you will.
Like, all these kids are breaking up area of rectangles. What are you doing?
So I think that I could say I want to do 5 times 6. Put those
like this 5 and that 6, the 2 in the middle. Okay.
I'm going to call that 30. 30. And then I'm going to multiply by 3 next.
Okay.
For 90. And then I want to do 90 times 6 is 540, because I know 9 times 6.
Okay. So just so everybody knows what I've got on the board. So I rewrote 15 times 36. Underneath it, the quantity 3 times 5 times the quantity 6 times 6. And then underneath that, I kept the numbers in the same place. I wrote 3 times the quantity, parentheses around, 5 times 6 times 6. So it's 3 times parenthesis 5 times 6 and the parenthesis times 6. Underneath that, I wrote 3 times, that 5 times 6 is 30. So 3 times 30 times 6. And underneath that, I wrote 90 times 6 equals 540. Nice, flexible factoring. Now, depending on how much time I have, at this point, I might say, I wonder if anybody could flexibly factor, or did anybody flexibly factor differently?
Mm-hmm.
I'm looking around the room. I am kind of curious, Kim, do you have a different flexible factoring, or is that's probably the best one?
Yeah, if you know 30 times 18, like if you know 3 times 18 is 54. I mean, I don't know that.
Yeah. And I think you got that by factoring the 15 into 3 times 5 and the 36 into 2 times 18. So now you end up with 5 times 2 in the middle times 3 times 18. And you're like, meh.
Wait, say that again? No, I did. I did 5 times 6 is 30, and 3 times 6 is 18. So then I did 30 times 18.
So you kept it factored the same way, and I factored it slightly differently.
Yeah.
So I was thinking about 3 times 5 times 2 times 18.
Mm-hmm.
And then the 5 times 2 becomes 10. So I end up with 10 times 3 times 18.
Mm-hmm.
So then you might be at a place where you're like 3 times 18, really. But you could do that if you kept factoring that 3 times 9. That's 27 times 2 to get the 54 times a 10. Anyway, so some ways that we could play around with flexible factoring. All right, kid number 7. What do you got?
I could see the other kid saying 15 times 36. I'm going to double half and turn that into 15 times 18, 30 times 18. Sorry. And
so I'm drawing 15 times 36. I'm drawing that rectangle, but you want to, what part are you doubling?
I'm going to double the 15.
Because that's a nice 30.
Mm-hmm. And then I'm going to half the 36. And that's going to turn it into a 30 times 18.
And now we're stuck back at that 3 times 18.
Mm-hmm. But I could do it again and then get 60 times 9.
And I'm drawing. Let's see, I got to cut that in half. And I've run out of room on my paper.
Me too. I had to move it somewhere else. And then I have 60 times 9, which is 540.
And 60 times 9, which is 540. Nice. All right. Now we're going to have another class conversation. What do you think? Which strategy do you want your brain to be inclined to do next time? And why? Turn and talk to a partner. And then I'm going to go listen in, and I might call on 1 or 2 kids to just chat about, really, at this point, it's not whether a strategy wins. I'm going to try to get kids to talk about their thinking. Yeah. All right.
Yeah.
There's my problem talk.
Okay.
Woo!
You and I think do them a little bit differently, which is fine. I wonder about you have me thinking about how much instruction I do in the middle of a problem talk or along the way. Like there were a couple of moments where you said that you would have them reflect and compare and like come up with another strategy. Like if one kid had done a flexible factoring and then maybe say, could we do it another way?
Could we think of
Um,
another flexible
yeah,
factoring way?
it's one of those things where I don't know that we've ever been in the same room as each other doing a problem talk. So that might be a fun thing to do. When we traveled and presented together for a lot of years, we would see each other do something and go, "Huh, why do you do it that way?"
Mhm.
So this is raising some questions for me about when we would do what. I think when I do them, it's more like information gathering because I want to know what students are thinking about. And so I wonder if mine go a little more quickly than
Mhm.
yours. Um, I think there's definitely for me in my mind this step back towards the end that you just mentioned. Yeah, I'm thinking. I do have some questions.
Okay.
When you circulate
Mhm.
and you're looking at papers, are you purposely calling on someone? How are you getting, we had Kim 1, 2, 3, 4, 5, 6, 7. How are you deciding who you call on?
So first of all, good point that I'm definitely deciding who I'm calling on.
Mhm.
And so it might depend on the goal of the day. And for today, I wanted to compare the major strategies that we had developed. And so
Mhm.
I was looking for an example of those major strategies.
Mhm.
Um, the kid who talked about repeated addition would have been, I think, would have been me thinking the kid was doing something different. So I
Mm.
don't know that I would have called on the repeated addition
Okay,
kid
that's good to know.
in this case. So because I
Which
always go ahead.
No, can I interrupt? Because
Yeah.
there might be people who push back and say, "Well, why'd you call in?" and then not represent their thinking. So you didn't necessarily know the things that I was going to say,
Yeah.
but if you were seeing, you would acknowledge, high five them for thinking about the connection that that's the problem you're solving, but not call them up and then say, "I'm not representing it."
Yeah.
Yeah.
Yeah, it's a little tricky. I definitely want to make sure that the kid is respected for their thinking and that we've honored the fact that they've dug in and they've done fine. They're thinking about 36 15s and they chose to add up 15s instead of add up 36s.
Hmm.
I could back up a little bit. If I'm doing this early and I have a lot of kids that are doing repeated addition and or even a handful of kids that are doing repeated addition, then we need to do more work here. In that case, I might have said, "Hey, you who added up the 15s instead of added up the 36s," so that the kids who were adding up 36s could go, "Oh, look at the numbers before you just start adding." Adding up those 10s and 5s would have been so much easier than all the work I did to add up 36s.
Hmm.
Like that could have been a conversation. I chose having a feeling that you were going to come up with flexible factoring as one of the strategies. That says to me that I don't have a lot of kids that are doing repeated addition. So, how do I say this? I want to honor all kids' thinking by letting them solve the problem any way that they want, interacting with them as I'm circulating. Then I'm going to move the math forward by purposefully choosing specific strategies to compare. All
And
right.
that's important to note because there are a lot of people who love problem talks as a way to have students share what they're thinking and choose to say everybody can share. We're going to put lots and lots of things on the board. And I think what you're saying for you, problem talks are about instructional moves and they are still about purposely choosing what goes up to move the math forward. And I think that's a big distinction that people need to take away from this, that problem talks for you are not just anything goes, put everybody's up as a celebration. They're still instructional.
Very much so. Yep.
Okay.
Yeah.
I think one more question is we had Kim be a student each time, and so you looked for specific things. How many kids do you have in mind that you would call on? Like you purposely planned ahead of time what you thought about. You said you were looking for strategies. Is there a number of kids that you think about when you have share?
Yeah, I'm kind of aware that I almost wish we would have done this podcast slightly differently, because I might be giving the impression that it's like anybody else, where really I do think I would have, and it's just kind of the way we set it up today.
Yeah.
Really in a classroom, I would have gone to find the strategies that I think will move the math forward. And I don't think I would have called on 7 kids. So depending on what the majority of kids are doing, I want to choose to share something that will help link what they're doing to what's to something more sophisticated. If that, I don't know, a different way to say that. So
Yeah.
probably 4 would be around the number. So maybe 3, maybe 5, but probably 4 kids is yeah, maybe 3 sometimes. It's not about getting everything on the board. And I fear that we might, so we didn't, maybe we gave that impression today, just the way we sort of set it up in the podcast. When I'm in class, I'm going to be intentional about who I'm choosing. And I think 3 to 4, maybe 5 is going to be the max that I might have share.
Okay. So one of the things we didn't mention that is important to mention is that a problem talk needs to be a really rich problem so that you can get the strategies to come out that you're looking for. So 15 times 36 was a fantastic problem because there's a lot that you can do with it. What may not make a great problem talk is a problem like 47 times 99. Say more about why that's not a good problem talk.
Yeah, that's a good choice. If we give the students something like 47 times 99, we're really hoping that they're going to choose an over strategy, because almost everything else is just less efficient. Like the over is so efficient, and so it uses place values. We're hoping to develop the intuition in students so that when they look at a problem, they ask themselves, what will work well here? What do I know that I can use? Yeah. And we hope we've built intuition for that particular strategy, that for those numbers that they can choose well. And the only way that we can do that is doing it, like giving kids problems, comparing strategies and going, why for the what is it about these numbers that nudged you that way? Now we learn. And then hopefully we get better at that.
Yeah. Okay. I hope that you like what you've put on your paper, because we are going to capture that image and share that so when people listen to this episode, they'll have a place that they can go and look at what your final blog will look like.
Sweet.
That'll be fun.
All right. Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. And thanks for spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, join our free challenge. It's happening now, January 21st through 23rd, 7 p.m. Central. Go register and join us.
That's mathisfigureoutable.com/challenge. See you there.